Hello, welcome back. Today we're going to cover the next lesson of this Desmos SAT course. And today we're going to be focusing on evaluating, combining, and composing functions. And using Desmos because there's one thing that's probably the most favorite thing I love about Desmos. It's its ability to just simplify functions, right? That's kind of the most interesting and I like to say the most satisfying part of using Desmos. So let's get right into it, right? So SAT function questions, they often ask for an output hidden inside notation, such as, f of 4 or 2 times f of 3 minus g of 3. So some harder questions, they place one function inside another. Those are called composite functions. And Desmos understands each form directly, right? You just define a function once, then you enter exactly what the question asks for. So let's get right into it, right? What do I mean by define once? Well, if you have a function like f of a equals b, and don't look at the graph here for a sec, just look at this part, right? Let's say f of a equals b, right? That means that a is the input and b is the output, right? So to evaluate a function in Desmos, you have to enter the definition. So for example, right, let's say your function in the given problem is f of x equals x squared minus 4x plus 7. So that's the function. You move to a new expression line. So go to the second line here, and let's say you're trying to find the value of that function at x equals -2. Well, what you do is since you're plugging in -2 for x, right? That's your input. You'll just do f of -2, and look, it tells you it's 19, right? It's so like convenient. So that's kind of what I mean by defining your function and then plugging in an x value to kind of evaluate it, right? So this is one of the most amazing things about Desmos, right? But then, uh, when should you actually evaluate a function in Desmos, right? You should use Desmos when a function definition is given and the question asks for one or more outputs, right? Kind of like what I showed you here. You should use Desmos when your input is negative, it's a fraction, or it's inside a longer expression. So in this case, it's -2, and this would be one case where you would use Desmos, right? Sometimes they ask for combined outputs. I'll get to that later in this video, but again, that's another use case, right? There's composite functions, and that's kind of some of the use cases, right? Now, when should you not use Desmos? When the rule and input are simple, right? For example, if you have let's remove this for a sec. Let's say if you have like f of x equals 3x plus 1, right? You don't really need to use Desmos for this type of function because, like, let's say you're trying to find f of 4, right? You can just do 4 times 3 plus 1, right? It's something you can just do mentally, right? You don't need to put this into Desmos. So it's only those very sophisticated and complex function definitions where you actually need to input this into Desmos. So moving on, right? Let's say sometimes you have functions that are defined, right? And what Desmos can do is it can actually use them in longer expressions. So for example, let's say you have a function p of x, that is not x, okay, p of x equals 2x plus 3. And then you have another function, right? This is the amazing thing again. You can graph multiple functions. You can have q of x equals x squared minus 1, right? Now, let's say you're trying to find the value of p of 4 plus q of 4. Well, without having to do it manually, which you could, right? I can easily see myself doing this mentally, but all you got to do is just type it in. Like, so you can say p of 4, right, on one as the first part, and then plus q of 4. And look, it gives you 26, right? That's exactly what the answer is. It's 26, right? So that's what I mean when I say that you can have once you define these functions, p of x and q of x, Desmos can literally use them in longer expressions, like the one here that gave us 26 as our outputs. So that's again kind of really, really satisfying part of using Desmos, right? Um, let's go on to another example, right? Sometimes you have composite functions, right? So let's say you have the function h of x equals x squared plus 2x, right? And then you have another function j of x which equals 3 minus x, right? Now, let's say Desmos is asking you to find the value of h of j of 5, right? You might not know how to do that necessarily, and it is okay if you forgot. It is something you should definitely know. You should definitely know what composite functions are. Um, but let's say you're trying to find the value of h of j of 5. Well, guess what? Desmos can literally do it for you. It's right here, right? You don't need to do any more extra work. If you do h of j of 5, well, guess what? You get 0 as your answer, right? And that is the answer, right? It's so convenient. It just does it for you. You don't have to know what j of 5 is. Um, and just to kind of verify, if you plug in j of 5, right, you get negative 2. And if you do h of negative 2, you do get 0, right? So once again, Desmos is amazing, right? It does this for you easily, so effortlessly, right? Um, Now, let's say you're given a function in context, right? So, for example, suppose you're given the function d of t equals 55t, right? So again, d of t, let's call this d of x. I always love using x, so 55x. And d of t gives you, I'm going to say d of t. I know it's d of x on there, but let's say d of t. So suppose that d of t gives you the distance in miles after you travel t hours, right? So if a question is asking you to interpret what is d of 3, right? Of course, right, if you plug it in, you get 165. But more specifically, right, in context, it means that after 3 hours, right, the distance traveled is 165 miles, right? So, yep, right, you should definitely use definitions, but also make sure you understand the context, right? You should understand what those x and y values, those inputs and outputs really mean. So that's again kind of another use case of decimals, right? Um, Sometimes, right, I kind of showed this to you earlier, but let's say you have a function r of x, and that equals x squared minus 2, right? And let's say you have another function called s of x, right? And that gives, let's say that's equal to x plus 4, right? So s of x is equal to x plus 4. So you have those two functions. And then they give you a new function v of x, which is defined in terms of the other two functions. So let's say it's 2 times r of x uh, minus s of x, right? So it's the blue function there, right? So why is this important? Well, because now if you're trying to find the value of v of 3, instead of going through, those steps, you can just plug in 3 into v, right? If you input 3, you get 7 as your answer. And guess what? That is the answer, right? 7 is what you should get after you go through this entire process. So this is what I absolutely love, right? Is that it's not even just the fact that you can have one function definition, but you can have one function definition, you can have two function definitions, and you can have function definitions written in terms of other function definitions, right? I know I'm saying function definitions a lot, but like again, this just shows you how powerful Desmos is and how it really does save time if you use functions in Desmos, right? So that's kind of all I do want to say for using functions, right? That's kind of really it. Um, I think the most important takeaway from this is for those word problems, right, where you might be given a function, and they ask you to interpret a value, in given in the problem. Just make sure you use context, right? It was kind of referring I was kind of referring to the example I gave you earlier, right? Where you might get a point, but make sure you know what that point actually means in context. Make sure you know what the inputs and outputs are. And once you understand that, once you do a lot of practice problems involving those types of questions, I generally think Desmos is your superpower for functions. But that's really it for this lesson. I hope you enjoyed. If you have any questions, leave it down in the comments and stay tuned for the next lesson in this course. Thank you.